After traffic starts and reads its static configuration, it will listen on the entry points and start polling the providers to build the dynamic configuration. A provider fits into one of 4 categories that determine where in that provider's resources you'll put the configuration for traffic proxy. For example, the Docker provider is label-based, so you would put traffic's configuration into labels in your Docker Compose file. Traffic picks these up from the Docker API and builds the dynamic configuration. The Kubernetes ingress provider is annotation-based, so you would annotate the ingress or service resources in your cluster, and traffic proxy would do what? It would pick that information up from the Kubernetes API and build the dynamic configuration. Besides the label and annotation types, you can have key value pairs stored in something like etcd, Zookeeper, or Consul, or you can use files, which is what you would use if you had traffic running on bare metal. The Kubernetes CRD provider is technically a file-based provider because the entire manifest represents a component inside of traffic proxy. You could, if you wanted, add files as config maps inside of Kubernetes and attach them as volumes to the traffic proxy pod. You could use this to enable traffic proxy to work with services outside of the cluster. With the dynamic reloading of config maps inside of the pod, traffic proxy would pick up the file changes and update the dynamic configuration. In Kubernetes, we use namespaces to prevent name collisions. Service foo in namespace alpha is completely different from service foo in namespace bravo. Traffic proxy has a similar architecture for its providers, and when you want to reference a resource in a different provider, you include its namespace with an @ sign. For example, if you were working with an ingress resource and you wanted to reference a middleware named middleware redirect that you created with the Kubernetes CRD provider, you would call it from the ingress as middleware-redirect at Kubernetes CRD. If you wanted to use that middleware from within an ingress route resource, which is already part of the Kubernetes CRD provider, then you would just reference it as middleware-redirect. This lets you reuse resources and mix and match providers. Maybe your middleware is stored in an etcd or a Zookeeper data store so that it can be used by traffic proxy running in both Docker and Kubernetes. Do you see how you can start to assemble a modular system that serves your entire environment? The first of our dynamic configuration resources is a router. A router receives a request, analyzes it, and connects it to a middleware or service. Once traffic enters on the entry point, it's received by a router. This looks at protocol, path, hostname, and TLS configuration, and then it decides what to do with it. If it's a TCP router, then it just passes it through, maybe doing TLS termination. If it's an HTTP router, then it can make decisions based on SNI header, path, hostname, and other layer 7 attributes. In its default configuration, a router passes the request to a service, but it can also pass the request to middleware. Middleware alters the request before handing it off to the service, or if it's an outbound traffic, before handing it off to the router. Middleware is how you make your traffic proxy installation into some beastly powerhouse of edge processing. Middleware exists for local and forwarded authentication, compression, rewrites, redirects, buffering, circuit breaking, rate limiting, retries, error handling, and more. You can chain middleware together so that a request passes from one to the next before continuing on its way. A service connects a request to the backend servers. This is the final piece before a request exits traffic proxy and goes to a backend server. Services handle load balancing configuration like session stickiness, mirroring, weighted distribution, canary testing, and blue-green deployments. In Kubernetes, we think of the Kubernetes service as handling this piece, but the real value of a Kubernetes service is to provide a stable hostname and IP that maps to a group of pods. Traffic proxy has a much more comprehensive configuration for load balancing than a traditional Kubernetes service, so it only uses the service to get the list of healthy pods behind it through the endpoints resource. It then sends traffic directly to those pods and just bypasses the Kubernetes service IP entirely. If you think about it, this makes sense. We don't want traffic proxy to load balance one IP address and then in turn have that load balance the actual IPs with a different algorithm. We just want to go directly to the pods themselves. When working with the Kubernetes CRD provider, each custom resource maps to a traffic object. An ingress route is a router. There are three types: ingress route for HTTP and ingress route TCP and ingress route UDP for their respective protocols. A traffic service is a traffic HTTP service, not a Kubernetes service. If you're not messing around with mirroring or session binding, then you can just use a Kubernetes service as the target in your ingress route. But as soon as you want more control, you'll use a traffic service. A middleware resource maps to middleware. That one's easy. There are additional custom resources for configuring TLS options, and these map directly through to the traffic objects of the same name. We won't get into those in today's class.